All right. Let's move on to another, like a cousin of an experiment. And honestly, in personality theory, this is the much more common design, the quasi-experiment. Quasi means sort of, it means not quite. So it's kind of an experiment. It's not quite an experiment. It's close. So I'm going to use this study that I found, concurrent and lagged effects of counter-dispositional extroversion on vitality. Oh, that sounds exciting. All right. So in this study, employees were the participants and they completed an extroversion test. Based on that test, they were sorted into groups: low extroversion employees and high extroversion employees. Okay. So we used a trait that they possess to sort them into groups. And we're going to use that as our independent variable. All right, I told you in the last lecture that the quintessential key for something to be a true experiment is that you have to have the ability to randomly assign participants to groups. Obviously, we can't randomly assign people to groups when we're using some quality of the participants as the mechanism for sorting them into groups. So we're using this as an independent variable, but it's not a randomly assigned one. So the low extroversion participants are in one group, the high extroversion participants are in the other group. Then we measure their vitality, and that was referring to like how excitable they were, how energized they were, how engaged they were. We measure their vitality immediately, and then we measure it again an hour later. It's a pretty complicated study that I pulled as the example, so I'm not going into all the details. We're going to use these two vitality measurements as the dependent variables for the study. All right, so just to give you the roundness of the outcome. So immediately, so like when the experiment first starts and we've measured them and now we're having them engage in some things, immediately there was really no difference between the low extroversion and the high extroversion group. They seemed the same. But an hour later, they found that the high extroversion participants were continuing to display vitality that had started to wane in the low extroversion group. The researchers actually made the argument that if you ask a low extroversion person to behave in an extroverted way, they can do it for a little while, but that it starts to become taxing. And so after an hour has passed, you start to now see the difference in behavior between the people who are naturally more highly extroverted and the ones who had behaved in an extroverted way at the beginning, but now that it's draining and they can't really carry it off anymore. So that was the argument they were making. Here's the problem. Because we can't randomly assign people to be low extroverts or high extroverts, we run the risk with quasi-experiments that there might be something else going on that's systematic that we can't control for. So quasi-experiments are not going to be quite as secure as a true experiment. So let's talk a little bit more about this. So we've got we're starting off the same way. It contains variables, factors that vary in some way. There's an independent variable. Here, the difference is we're going to use naturally occurring characteristics as our independent variable. So a really, really common one in psychology research of all types is sex. So we sort the males and the females. They might sort you into age groups, have the teenagers versus the emerging adults versus the full-fledged adults. So they may, anytime you're sorted into groups based on some quality that you have, that would be an example of a quasi-experimental independent variable. So you have the independent variable or not, or you have it to some degree or not, and that's how we sort you for the independent variable. Dependent variable is, again, still going to be, the participant produces it. We're hoping that it's being affected by the independent variable. It's just that in this case, because the independent variable is non-random, right? The person came in whatever sex they are, or they came with whatever personality traits they have, or they came in whatever age group they belong to. We don't have that random assignment. And so we're going to be less confident about cause and effect because we don't control the independent variable. We can't randomly assign participants to those groups. But I have to say, this is the only way we can study certain questions. I mean, if we want to see whether males and females score differently on something, there's no way that we can take a group of people and randomly assign some of them to be male and some to be female. Like, you can't do that. Obviously, it doesn't. That, like, it would be meaningless to do something like that. If we thought, that whether your parents were divorced in childhood or not might be an important factor. Well, we can't randomly assign some people to have divorced parents or not. We can't, like, we physically can't do some of it. Some of it, sometimes we use quasi experiments because, well, maybe it would be possible to randomly assign people. It would not be ethical to randomly assign people. So, for example, back in the olden days when we were trying to establish whether smoking actually causes cancer, they subjected mice and rats to, be exposed to smoke or not. But you can't do that with humans, right? Like, you can't randomly assign some people to have, to smoke, to have parents who smoke, or these kinds. You can't do that. You can't randomly assign people to have a healthful diet and some people to have an unhealthful diet. You can't do that. It's not ethically appropriate. So we have to then use existing groups who choose to eat a healthy diet versus people who choose not to, and people who choose to smoke versus people who choose not to, things like that. And so what that means is there may be other things that are going along with their choice to eat healthfully or their choice to smoke or whatever we're measuring. There may be other things that go along with being male or female that impact the dependent variable that aren't really just about sex, but are about other things. So with quasi experiments, we can't be quite as confident that the outcome is due strictly to the independent variable. It might be due to something else. So it's a little muddy, but we're willing to take this risk because we can't get the data any other way. How about correlational studies? Okay, this is the most common research style that you are going to see in your textbook. Correlational studies. So as an example, I'm going to use this one, the relationship of personality traits and entrepreneurship tendencies with career adaptability of nursing students. Okay, so in this study, the variables were a 10-item personality inventory that measured basically the big 5 traits, the scale of university students' entrepreneurship, and then the career adaptability scale, and it has 4 subscales. All right. So these are our variables. You'll notice there's, I didn't say something was the independent variable. I didn't say something was the dependent variable. These are just variables. And then what you do in a correlational study is you look to see whether the variables go together or not, just to attract you to the important things. So under column 1, what we're looking at is whether extroversion correlates with each of the things that's listed on the left. And I think the important ones are the ones that I put a square around. So extroversion correlates with entrepreneurship, concern, control, curiosity, confidence, and then the total score for CAAS. Those asterisks next to the numbers indicate how significantly they correlate with each other, which is just a measure of how likely this data would be organized like this purely by accident. So don't think, oh, more asterisks means it's more meaningful. It just means it's just a statistical term. It just means that this wouldn't have happened by accident, except for 1 time out of 100 is what those double asterisks mean. Let me draw your attention to the numbers that are there, the 0.33. I told you earlier that in a correlation coefficient, the number can range from 0 to 1. And then it can be positive or negative. That's independent of the value of the number. So 0 to 1 is what we're talking about. The closer you are to 0, the less correlated the variables really are. And so what you're seeing in this column is nothing is greater than 0.33. So they're not very strongly correlated with each other, but the organization of these numbers probably didn't happen by chance. You'll notice that agreeableness doesn't really correlate with any of those variables. Conscientiousness correlates with all of them, just like extroversion had. Emotional stability correlates with some of them, but not all of them. And look how weak the numbers are. They're the 0.14 and the 0.2. We're getting very close to 0 on this measure. Here we have openness to experience, and we see that they're correlated. This is openness being associated with entrepreneurship is the highest correlation we've seen so far. Here we're looking at entrepreneurship correlating with other things, and you'll notice that entrepreneurship correlates very well with the subscales of the CAAS. And so anyway, this is the kind of results that we can get with a correlational study. So let's describe what we're talking about here. So again, variables are factors that vary in some way. Okay. There is not going to be any kind of independent variable in a correlational study. All you're going to have is two dependent variables. Now in the last slide, in the study I just described, you're like, wait, there were three variables. Did I lose my mind? That was three. You can only compare two at a time. So that's what you notice in that matrix, is that you were comparing two variables to each other at the time, seeing if they went together. So that's what I mean by two dependent variables. You can have as many dependent variables, pushed in there, but they are only going to be compared, two at a time. Both of these dependent variables are scores that the participant's going to produce, right? So those participants took those scales and produced a number. And what we're looking for is to see whether those scores are related to each other. There's no participant assignment in a correlational study. Just everybody produces their scores on the dependent variables, and then we use statistics to determine whether they go together or not. Whether we can make the assertion that knowing a score on one of the scales helps us to predict what your score on the other scale might be, is kind of a way to think about correlational studies. There are some significant problems with correlational studies because we have absolutely no control over anything in a correlational study. All we can say is that these variables go together. That's all we can say. We can't say that one of them is causing the other. We can't say that that there's not some third variable causing both of them, and this correlation that we're seeing is just completely what we call spurious and really not meaningful. We can't say that. All we can say with a correlational study is that these two scores go together. And so it gives us the basis for hypothesis development and maybe the rationale for developing a quasi-experiment or a full experiment, but it doesn't really give us any kind of cause and effect capability. Now, everybody all knows that. I mean, there are people who I've seen students wearing shirts that say correlation does not establish causation. Like, people know that we're supposed to be wary of correlational studies. But then when I give you an example, like for example, the American Academy of Pediatrics reported that for every hour beyond 1 hour a day of screen time, for every hour beyond that, there's a 2% increase in the BMI of a child under the age of 17. My students immediately go, well, of course, if you're spending a lot of time in front of a screen, then that means you're not getting enough exercise. They go exactly right to a causal explanation for what is correlational data. I mean, it's completely possible that a person is spending more time in front of a screen because they already are overweight, right? Not because being in front of the screen doesn't necessarily make them gain weight. Maybe they're watching, maybe the amount of screen time is being caused by their weight. So if there is a causal relationship, we don't know which way it flows in a correlation, whether, weight is causing screen time or screen time is causing weight. We also don't know whether there's some third variable that's causing the relationship between these two variables. So maybe the reason why a person has a lot of screen time and is overweight is because, they're below the poverty line. Their parents aren't home, so they have time to watch TV or be on their screen. And because they're below the poverty line, their diet isn't as healthful as it would be otherwise. So this third variable of income might be the key factor that's causing both the weight and the screen time. So we just have to be, even though it sounds really obvious, well, of course, if you're watching a lot of screen, you're not getting enough exercise. We have to be really careful when we hear about correlations and always be thinking to ourselves, okay, my immediate thought was this causal flow. Could it flow the other way? Right? So immediately I thought, too much screen time, that makes you fat. Maybe being fatter makes you do screen time. Or think of a third variable that would account for both of those things. And that'll always help you to be skeptical of correlational studies. All right, that concludes our combo presentation of chapters 1 and 2. So I will see you next in chapter 3.